A very good morning, good afternoon, good evening to all my dear friends, students and participants for this NPTEL MOOC course, the title of which is Application of Forecasting, Regression and Time Series Models. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, as you know, there are three main topics or broad topics. Number one is forecasting, number two is regression, number three is time series. And we are covering the concept of regression models. This is week 7 and lecture number 35. So that means with this we will end the 7th week for this 12-week course, the total duration being 30 hours, which means 60 lectures. So, the coverage today would be for this lecture would be example of simple linear regression in finance, then example of multiple linear regression in finance. And as I said that the coverage, depending on what we are able to do that, the slides will be prepared accordingly. Now, as we had mentioned or as I had discussed in the last class, that you can either use the idea of capital R or small r. One is the total return, one is the rate of return. Capital R is given by the ratio of P2 by P1, where P1 is the price for today, P2 is the price for the next time period, and small r is the denominator remains P1, while in the numerator it is the difference between P2 and P1. For stock prices indices, assuming they are log normally distributed, we will consider R as not equal to P2 minus P1 in the numerator divided by P1. We take the concept of ln of P2, which is SP2. SP2 means the stock price for time period 2 divided by SP1, which is the stock price for time period 1. Technically, it means that we are taking the ratio and then taking the Neperian log or the natural log. Now, just for information, it is not relevant for this course, but the concept of continuous compounding interest rate comes from the fact that you are utilizing the value of small r, which is the rate of return expressed as in this formula, which is ln of P2 by P1 or ln of SP2 by SP1. In place of R, capital R, we can also use small r and do all the calculations what we have discussed in the last class, and the analysis would remain the same as we have discussed. In case, just for information, in case beta naught is 0, there is no systematic risk. That means the concept of the risk corresponding coming from the so-called, on the right hand side there were two terms. Number one is basically the risk coming from the market, and number two is the risk coming from white noise. And if beta naught is 0, then the risk factor coming from the market would be 0. If beta is 1, then we have systematic risk as the market portfolio. In that case, we know all the information from the market would be such that the increase and decrease of the corresponding rate of return or total return for the stock is totally dependent on the market with the correlation coefficient of 1 plus 1. So, we can easily show, if we further go into the details, I am not going to go into the financial aspect, that the total return RP bar can be expressed as RF. RF is the treasury bill 91 days interest rate. All interest rate would be expressed as continuous compounding minus beta RM minus RF. So, this minus and plus I am denoting that the market is uncorrelated for the case when beta is 0, positively correlated when beta is 1, negatively correlated when beta is less than 0. And we know the value of the beta value would give you what is the rate of change of the corresponding return of that particular stock with respect to the market. And also we would know that just I am stating the beta p is the beta value for the portfolio is given by the correlation coefficient of the portfolio with the market, which, as you know, correlation would be between -1 to +1, and in the numerator and denominator you have actually sigma p and sigma l, where They are the standard deviation of the portfolio and the market. Now, remember the sigma value which you have, the rho value, sorry, the rho value which you have, rho suffix p and m, gives you the relationship as I mentioned between the market and the portfolio. So, if it is 0, no relationship, plus 1, 1 to 1 correspondent is always in the positive direction or the negative direction depending on which way the market is moving, and if it is negative minus 1, it means the market and the corresponding portfolio are in a way related such that they move in opposite direction. Now, we will solve a very simple problem, but with real data, and this is example number 24. Considering the data for the closing price from the NSE and Tata Motors for the time period of February to June 2025. I am not utilizing the data to show here, but I will actually show you the calculations and the end result. So, we plot the values of the return using the simple linear regression model of the form that, if you remember, you have R bar I, which is equal to R bar Tata is equal to, Tata suffix means for the Tata stock, is equal to alpha, which is for the Tata Motors, plus beta of the Tata, which is beta for Tata Motors, into R bar NSE 50. That value comes out to be alpha being minus 0.0013 and the value beta comes out to be plus 1.2845. So, I will now switch on to the Excel file. So, this is the regression model and we have the data corresponding to the Tata stock value. So, this is the data which we have. This is the, I will remove, this is the time period. If you remember, we had said I will switch between the Excel sheet and the PPT slide. We had said the time period is from February to June. So, we start from 1st February and go to 30th June, which is given in column number D. The NSE, now by the way, the prices for any stock is an opening price, closing price, maximum value, minimum value. We always take the closing price because that gives us the maximum information pertaining to the fact that how the stock or the portfolio is behaving with the market. And also we have the Tata Motors prices starting from 706.55 and last value, which is for 30th June, is given as 688. Now, we convert them into the return, and if we remember, the return can be calculated by total return, can be calculated by rate of return, and for the rate of return we have two formula. One is given by P2 by P1, another one is given by ln of P2 by P1. We use the concept corresponding to the continuous compounding interest rate, hence we will take the logarithmic of this ratio, and that value is given here in column number G. If you click on the first element, it gives you the logarithmic value, natural logarithmic value of P2, which is 2 for NSE I am finding out, and the price is given as 23,361. I am not reading the decimal. So, is ln of 23,361 and the denominator which you have is 23,482. The value of R comes out to be minus 0.00517, which is given in the cells G293. Similarly, if I go to the next value, it is the ratio of ln of 23739 in the numerator. Again, I am not reading the decimal, and in the denominator you have 23361. If I continue doing it, I have in the last cell the return which is given for the NSE for the 30th of June 2025. Similarly, if I go for Tata Motors, I will remove the graph more to the right hand side. This is given by the corresponding ratio which is given for the prices in column number F. So, the first value is ln of 687 by 706. Again, I am not reading the decimal. The next value comes out to be ln of 710 divided by in the 710 in the numerator and in the denominator 687. Based on that, when I do the calculation, the last value comes out to be plus 0.0016. So, actually you have NSC value, which is the independent variable, which would be x, the Tata Motors value would be y, and based on that I plot all these values, and this graph is given here, which we were showing in the PPT file. This is the best fit line, and the actual equation comes, which I have repeated. Y is equal to alpha value of beta naught value is minus 0.0013, which is the intercept, and the beta value is 1.2845 into x. So, this is actually the equation which you have to predict the price of Tata Motors with respect to the NSE value for a time period which you have already mentioned. So, we plot the values which I showed, and the values of beta naught, which is alpha, and beta Tata, which is basically beta 1, are given as already mentioned. This is the plot. So, what we are doing, and obviously that would be very clear to all of you, we are taking the distance. This is the error term. This is the error term. I am just taking arbitrarily plots and marking where the error term is. This is the error term. This is the error term. That means you go parallel to the y axis. Then this is the error term. So, when I have all the error terms, square them up, all the time period, consider that for January, February, March, April, May, June, for the time period considering t, this summation of epsilon I square gives me the error, and then based on that error I minimize that with respect to the value of beta, which is unknown. If there is only one beta, and solve it to get the answer. This is what the actual practice and the discussion had been quite in depth in the last classes, set of classes. So, here again I am mentioning Tata Motor returns versus NSE 50 returns, and the equation is given. Using this methodology, we try to capture some of the non-market influences, because there is white noise which is not being reflected by the market price. Searching for the non-market influences, like searching for corresponding economic factors, they can be economic factors, price of rare earth, based on which the different type of components of the nowadays cars are made, or considering that if Tata Motors is making battery operated car or battery EV cars, then if there is a change in the material which is utilized to make those batteries, then it has a negative effect. If it is increasing, it has a negative effect on the price of the Tata Motors car. Or it can be for the diesel and the petrol cars, the effect is coming from the change in the Brent crude price in the petroleum market, in the oil sector. Or it can be related to US dollars to Indian rupees, UK pounds to Indian rupees. So, these are factors which we have not considered when we are considering only one independent parameter to find out the relationship between the market and the Tata Motors price. So, let me continue reading it. Searching for the non-market influence is akin to searching for corresponding economic factors, influences, or structural groups that account for common movement in the stock prices, which cannot be studied considering the market as the independent variable. So, there are some outside influence. This model introduces extra indices which we will consider with the hope of capturing the additional information which we are talking for the last few seconds. Now, we will come into the realm of discussion of multi-index model, which is exactly equal to the idea of multiple linear regression. Here, we need to predict the correlation coefficients, which we will do, to form expectations about returns and study the change in the returns due to the impact of these events. As I said, price of US dollars to Indian rupees, price of UK pounds to Indian rupees, price of Brent crude, price of any other raw materials which may have an effect on the price of Tata Motors scrips, because it will affect the share value price, it will affect the price of the vehicles, it will affect the cost, all these things would be affected. We need to find out the method of tailoring the return distribution of our portfolio to the specific need of the investor. So, the investor would depend on his or her risk appetite. This is, I am talking from the point of finance. And there is a method of attributing the cause of good or bad performance of a portfolio depending on how the market is fluctuating. So, if all the information is there in the market, obviously the market gives us the best inclination of the price fluctuation of a particular stock. If it is not, then there are external influences which we are terming as white noise. Now, let us come to how the multiple linear regression model looks like and discuss about that and then solve a problem. The multiple linear regression model, as you all know, there is y, which is Ri, which is the dependent variable, and on the right hand side of the equation we know there is beta naught, which is given, I will use a different color, which is given as alpha I, and the other corresponding terms are, I will read it and then I mark it. The second term on the right hand side is beta 1 into x1. It goes on, if there are k number of terms, the second last term would be beta k into xk, and the last term would be the error. So, if I consider beta 1 into x1 till addition plus dot 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 till beta k into xk, the terms are these. And the last term, as I mentioned, is the error. Now, in place of beta 1 till beta k, I have replaced them with bi1 till bil, where I am considering that you have the ith stock and I1 to IL are the corresponding factors or the independent variables which affect the price of the return, which is given by Ri. Again, very simply, we know that the error term is normally distributed with 0 mean and sigma square epsilon as the variance, and that is given by the first two equations already marked, and I will put a tick mark as per the assumption. I will come to the third one later. The fourth one gives you the independent structure between the independent variables. If you remember the concept of rank of x I mentioned. So, any independent variable which you have, set of independent variables which you have, consider k is 3. So, you have x1, x2, x3. We will consider that x1, x2, x3 are all independent of each other, and that is being portrayed in the equation, which I will put here a green tick mark, the fourth one. If they are independent means covariance is 0, which is basically implied here. The last one, where I will put the color violet here, or I will use a different color, sorry, light blue. It means the error term is not being, any information between the error term and the independent variables is 0. That means the covariance existing between the error term and the independent variables are 0, as shown here, which we have already discussed. And the one which is not marked, which is the third one, gives us that the variance of each and every term which you have from x1 to xk are being given their corresponding variability is given by sigma square ij, and obviously the question would arise that I have not written about the expected value of I1 to IL. It can be, as I have not written it. So, if I consider, then you would have the expected value for I, say for example, I1 would be given by I1 bar, that is the sample one. Similarly, if I find out for the expected value for IL, which is the last one, it will be IL bar. That would be collected from the data, and we are good to go to utilize and understand this formula, that it is a utilization of the multiple linear regression model with the assumptions to solve it, and we will solve this problem using a practical data as we did for the simple linear regression model, considering NSE 50 data point for Tata Motors for a particular time period which you have already mentioned, which was February to June. Now, few other related information just for the calculations can be done very easily. Point 1, when I need to find out the expected value of the return of that particular stock or the expected value for y when it is dependent on more than 1x, then when I take the expected value on the left hand side, I have, which I am marking, r bar I, alpha is fixed, so hence the expected value remains fixed, and the corresponding beta 1 into x1 till beta k into xk, which is given as b1 I1 till b1 bl il, they are given by this, which I have already noted in the last slide. And as per the assumption, expected value of error is 0, so the term does not appear. The next case I need to find out is the variance. So, when I find out the variance of the return, which will be given on the left hand side, I will mark in dark red. This is sigma square I. Epsilon alpha is a constant, it would not have a variance and its corresponding covariance with all these 1 to L, I1 to IL are all 0, and the variability of epsilon with error is also 0, because alpha is a fixed term. And if you remember, variance for I1 to IL is there, which is being marked here, and obviously this B1 to BL will all be squared as given here when I am putting a tick mark in them. And the covariance between these independent variables we have already considered 0 as per the assumption, so they do not appear. Covariance between the error term and these L number of independent variables is also considered, it is 0, it is not there. Only I have in the last term, which I will use a different color, is given by the variability of the error term. And if I consider the variability occurring between the ith and the jth stock, then it will be, as you know, given by the variabilities of each and every term. So, what I mean is this: the first part is the variability, which is B1 1 into sigma square I1 is actually given by the variability of the first x1. X1 means the I1, and similarly when I have for the last case, I would actually have the beta L B I L B J L, I J are for the stocks into sigma square L. Do not be too much bothered about the equations, we need to solve it in order to understand its practical significance. Some variables which are used in multiple index models are economic growth, business cycle, long term interest rate, short term interest rate, inflation, foreign currency, as I mentioned, rupee to US dollars, rupee to yen, rupee to UK pound, etc. There are many other things, Brent crude prices, maybe inflation rate, all these things. So, now I have copied here the formula which we have been utilizing for the multiple linear regression model, and we utilize this formula to solve. The first one is beta hat, which is the estimate of beta of the regression coefficient, considering they are more than one random variable, independent random variables. I will again repeat, the first term where I put the tick mark red is x transpose. The second one where I put a double tick is the x without the transpose, and both of them in the bracket, and you take the inverse. The third one where I put the three tick marks is again the transpose, and the 4 tick marks which I put is for y. All data information is there, you will utilize it. The second bullet point is the covariance of beta. It is given by sigma square is basically the variance which is there in the error. If you remember the error term variance and the concept that idea which I mentioned about autocorrelation, non-autocorrelation, homoscedasticity, heteroscedasticity, we are assuming them to be true. We have to check them. I am assuming them to be true because if I try utilizing all this information, it will take a long time in the discussion based on the fact we have to do some many statistical tests. Then again the second term is the similarly x transpose x, that inverse, and x square s square, which is actually the standard error square for the sample, is interestingly, and this is the interesting part, and why I am saying the interesting part, this will be appearing time and again later on. You have the terms are here where I put the green color is actually the square of the error, y minus x beta hat transpose into y minus x beta hat. Y minus x beta hat is the error, multiplying it twice is the error square, summing them up. And what is n minus k? N minus k is actually, n is the sample size, k is the number of independent variables. And we have already seen in the case of a one sample, I won't use the word one sample, my mistake, when you have only one random variable, we have seen that the corresponding best estimate of the population variance can be found out from the sample variance, and in that case you have this formula which I am writing in blue color. I think I have already written it in one of the class. So, this is the variability where xi minus x bar n is actually the sample average, not the population, because the population average mu is unknown. And that is why as you are utilizing the information from the sample once, hence it is to find out the actual sample mean value by x bar n, you lose one degree of freedom, that is why it is given by n minus 1. Similarly, if you have the sample observations related to the first independent variable and it goes to the kth independent variable, you are utilizing each set once, hence you are losing k degrees of freedom, one for each sample, that is why n minus k, and remember that. Now, we will come to some other important concept, and this is quite relevant for multiple linear regression. Now, the total error which you have, which is given by SS suffix t, and I am marking them in blue, the total sum of square errors, SSR is regression sum of squares and SSE is the error sum of squares, and they have, each of them have certain implications. So, the total sum of square of errors is basically the total quantum of error or the sum of the squares of the deviation. I won't use the word error. Now, that deviation comes from two facts. One is the deviation which is being explained and another deviation which is not being explained. That deviation which is not being explained is given by the third term, which is SSE, which is error sum of squares. And the component which is being explained is SSR, is known as the regression sum of squares. Now, if you pay attention to the formula, it will immediately make sense. The total sum of the square errors is the difference from the actual point yi to its average value, which is y bar. And if you remember, y bar, x bar are the points which satisfies the equation which you have solved earlier. Earlier means when we are doing the problem. Hence, ns is squared. So, you will take yi minus y bar whole square, and if I want to find out the average, I will basically utilize the value of n or n minus k or n minus 1 corresponding to how I am basically depicting the concept of an important idea of R square and adjusted R square, which you will come to that in due course of time. The regression sum of squares is given by y hat. Y hat is the predicted value minus y bar. So, one is the difference between yi actual value minus y bar, which square term gives me the total, the deviation, and when I am trying to find out the difference between y hat and y bar, squaring it, it gives me the regression concept which is being explained. and now and definitely the difference between them would give me the error component which is not being explained. That is given by yi minus y bar, which is very intuitive to form because that is the error. So, squaring of that gives me the concept of the error sum of squares. We will utilize this concept of SST, SSR and SSC in the due course of time within the next class. With this, I will end this class and I will copy this slide in the next class as that easy reference of this slide can be utilized to solve our problems accordingly. Thank you very much and have a nice day.